Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about seasonal variations across the latitudes. And in this lecture, we will be discussing on insolation. What are all the contents we will be discussing in this lecture? That are the solar energy received at Earth's surface and what are the importance of insolation, what are the factors that affects the insolation and insolation how it influences on Earth's temperature and climate and how insolation impact on human being. So, these are all the contents we will be discussing in this lecture. Insolation. So, the definition of insolation is the word insolation comes from the Latin word insolatia or insolare, which means to expose to the sun. So, which is exposed to the sun. The sun is the great engine which drives the all weather phenomena. So, all the denudational processes and it also supports the life forms of the earth's surface. So, it acts as a major great engine of the earth's surface. It has the amount of solar radiation received per unit of area at earth's surface. That is how much solar radiation which have been received per unit area at the earth's surface. So, that is the definition of insolation. The earth received only tiny fraction of total amount of sun's radiation. Why it is very tiny radiation is received? Because the earth is far away from the sun and earth is smaller than the sun. So, because of that reason it receives only the tiny fraction of radiation. Insolation is also known as incoming solar radiation. It determines the heating of Earth's surface. So, heat is generated because only of insolation. It depends on what are all the factors, that is latitudes, season, time of day and atmospheric conditions. It influences the temperature, evaporation and vegetation patterns. Solar constant. So, what is meant by solar constant? The solar constant is total radiation energy received from the sun per unit of time, per unit of area. What is 2 per is there, that is per unit of time and per unit of area, that is known as a solar constant. Approximately the 1366 kilowatts per square kilometer is received as a solar constant. The sunspot and hot spots, it is also known as faculae. So, what is meant by faculae? That is a blocking out of light. So, the light is blocked from the sun. So, that process is known as sunspot or hot spot or it is also known as faculae and it reduces the emission of the light for few months of a percent. Bright spot. Bright spot is also known as plages. It is opposite of sunspot and hot spot. So, that is the faculae. It is a gaining of solar radiation, that is light energy. The solar activity are more extensive and longer lived and brightness compensates for the darkness of the sunspot. So, it is the sunspot is compensated by bright spot. It is fairly constant with solar cycles by only 0.2% at a peak of 11 years solar cycle. So, 11 years solar cycle is catch, that is the 11 years is the solar cycle period. In that 11 years what is the solar constant, that is 0.2%. It increases by 10% every billion year as sun burns up its hydrogen. So, sun due to the burning process of hydrogen there is an increase in which year, that is billionth year, every billionth year there is about increase of 10%. Importance of insolation. So, insolation plays as a driving factor for Earth's temperature and climatic patterns. It also controls the atmospheric and the oceanic circulation. So, it is essential for the photosynthesis process. Without the incoming solar radiation, there is no process of photosynthesis. and it also affects the renewable energy potentials, that is because of incoming solar radiation only the solar energy panels have been fitted in the top roof, and then it is converted into renewable energy. It determines the seasonal weather variability. Next one is factors affecting insolation, that is what are all the factors which affects the insolation. The latitude, that is the angle of sun above the horizon. So, that is the major factor which affects the insolation. The next one is season, that is earth still change the solar angle. So, in the previous lectures we have discussed about the earth tilt. So, that also plays an important role in the insolation. Then time of day, that is whether it is a early morning or it is a sunset duration or it is a noon. So, that also affects the solar radiation. Next one is atmospheric condition, that is the cloud, dust, aerosols which reduces the insolation which is coming to the earth's surface. And then surface reflection, that is albedo, the snow and ice reflects more sunlight. So, these are all the major factors which affect the incoming solar radiation insolation. Angle of incidence, the first factor, that is the angle between the sun's rays and the surface normal. Here we all know that here is the sun rays is there. So, the sun rays, what happens, it is striking here, the amount of sun's energy received is constant. It does not differ, but what happens is the area which it receives differs. Here the area is very small, and the area, the sun rays which is received in the polar region is, it was larger area. So, because of this area difference, there is the receiving of incoming solar radiation differs. So, if you can imagine that heating a tumbler of water and heating a vessel of water. So, that difference can be observed in this particular process. It determines the intensity of solar radiation received. The higher the angle, what happens? Higher the angle, the concentrated energy will be received and high insolation process will be happening, and vice versa. If there is a low angle, there is a dispersed energy and low insolation is received in the earth's surface. It also explains the variation with the latitudes and season. So, in the previous lecture we have detailedly discussed about what are all the influence of latitude and what are all the effects of latitudes and sun rays. Because of that, how the seasons have evolved across the latitude. So, that process is explained here. Duration of sunlight, that is the length of a day. The length of the day is it is also affected by the total insolation received. If it is going to be a longer day, the more incoming solar radiation will be there. If it is going to be a shorter day, there will be a less incoming solar radiation. So, 12 hours day, 12 hours night means it will be a balanced one. If in winter case, what happened? It's the daytime will be shorter and night time will be longer. So, in such a way that it influences the incoming solar radiation. It also varies with the latitudes, the extreme variation in the polar region. Next one is seasonal day length, which changes because of Earth's axial tilt. Next one is distance from sun. So, distance from the sun. So, earth revolves around the sun in the elliptical pattern, okay, it is a revolve around in the elliptical pattern. The earth sun distance changes. In the year, what happened? Because of the rotation of the earth's surface around the sun, this process happened, that is aphelion in the month of July 4 and then perihelion in the month of January 3rd. So, aphelion means the earth is far away from the sun, and it is how much far away, that is 152 million kilometer far away from the sun, and perihelion it is closest to the sun. Okay, what is the how far it is close to sun, that is 147.1 million kilometer, it is close to the sun. So, because of this process, the solar energy at aphelion is 7% less than the perihelion. So, in the southern hemisphere. So, this was the important factor which we have to concentrate in this factor which influence the insolation. The next one is atmospheric effect. So, atmosphere in the lecture atmosphere we have discussed about clouds, dust, aerosol, the same factor which influence this incoming solar radiation also, that is the clouds which reflects and absorbs the solar radiation. It is a main process which is done by the clouds, and dust aerosols scatter. So, reflection is done by what? Clouds, and then scattering is done by the dust aerosols which is suspended in the atmosphere. And water vapor, what does water vapor do? Water vapor absorbs the incoming solar radiation. So, observing pattern is also here, and the pollution which also reduces the surface radiation. What happened? It restrict the terrestrial radiation to go freely to the atmosphere. So, this process is also one of the most important, and atmosphere again it filters the harmful ultraviolet radiation. In such a way, all the phenomena of atmosphere plays a vital role in the factor that incoming solar radiation. Albedo. Albedo is the fraction of incoming solar radiation reflected by the surfaces. That is, did the incoming radiation is reflected back in the same amount by all the surface? No. It differs from each and every surfaces. For example, if it is going to be snow or ice, it have the high albedo. The albedo ranges from 80 to 90%. The reflection will be 80 to 90%. And in water and forest, it has the low albedo. The percentage of reflection is 10 to 20%. So, in such a way, the percentage varies from one surface to another surface of the earth. The influences, it also influences the surface heating and local climate. So, because of this process, there is a differential heating and local climate varies. It also feedback effect is also there because of this albedo, the melting of snow and the lower albedo, and more the warming is there in the earth surface. So, it is a cyclic process. In such a way, it influences the incoming solar radiation. The next one is the seasonal variation of insolation. So, the axial tilt plays a vital role. Summer, in the summer season, sun is over the head and it have the high insolation, and in the winter the contrast, that is the sun low in the sky and have the low incoming solar radiation. And in the equator at the same time the small seasonal variation will be there compared to the polar region where there is a extreme variation, that is we have discussed midnight sun and polar night. So, these are all the processes which influence strongly in the incoming solar radiation. Next, latitudinal variations. So, the latitudinal variation, the equator, the 0 degree equator, the region which receives the maximum incoming solar radiation, and while coming to the polar region it gradually decreases in the northern and southern hemispheres. And the intensity also decreases from equator towards the pole. So, in the equator, if you move up or down towards the polar region, the incoming solar radiation will decrease, and it also influences the temperature belts and climate zones. So, in the previous lecture, the seasonal variation, so we have discussed this one. It explains the tropical, temperate and polar climates. Next one is daily variation of insolation. So, day to day we are experiencing this insolation variation. How? That is the sunrise. So, in the sunrise we experience insolation will be high or low. So, there will be a gradual increase in the incoming solar radiation. So, it increase gradually, and then in noon time what happens? Contrastly, in the noon time there will be a maximum receiving of incoming solar radiation. So, because the sun will be overhead at the equator, the autumn equinox is on 23rd September and spring equinox is at 21st March. So, this will be the process which will be happening because of this daily variation. So, in afternoon the gradual decrease, after reaching the noon there will be again gradual decrease. During the sunset you can witness this, and sunrise and sunset have the decreasing insolation receiving by the earth's surface, and in the noon time there will be a peak hours. The daily solar energy integrates to compute the radiation received. The graphical representation of insolations. How? That is, the insolations varies with the latitudes, season and day. So, in the graph there is a maximum in what? Is maximum in the equator. So, in the equator region there is a maximum, and towards the pole it is minimizing. So, this was the concept, and it helps to understand the, that is, climate modeling, and it also helps, this data also helps to estimate the potential solar energy. So, in such a way the insolation data and insolation pattern helps us. Global insolation distribution. How far in the world the solar insolation is distributed? That is the highest in the tropics. So, you can see in the map that in the tropical regions how it's very hot, and how far it is received, that is 200 to 250 watts per square meters is received in the tropical region, and in the polar region the receiving of insolation is lowest, and it is below 50 watts per square meters. So, in such a way there is a contrast between tropics and polar region. It also influenced by the latitudes, cloud cover and surface type. It's also useful for solar energy planning. So, how far the insolation is received? So, we could not plan the solar energy conservation in the polar region. So, we can only plan where there is an intense insolation. So, that can be done only with the help of the understanding of how far the insolation is distributed globally. Solar zenith angle. So, solar zenith angle is the angle between sun's rays and vertical direction. So, it also determines the intensity of solar radiation at a point. If there is a low angle, what happens? Higher latitudes receive the less energy. If there is a high angle, that is the higher energy received by equatorial region. So, that is, solar zenith is nothing but what is the angle of the solar radiation. It also changes in the day and seasons. So, this variation can be witnessed in the time of the day and seasons. Solar declination. Solar declination is the sun is directly over the head at noon. So, in the previous slide we have discussed that at the noon time there will be a peak receiving of incoming solar radiation. So, that concept you have to remember. It also varies between 23.5 degree north and south, that is a Tropic of Cancer and Tropic of Capricorn. So, it determines the solar angle and insolation. It also influences the length of the day, how far the length will be there, and how far, what all the season which will be experienced. So, this is determined only by the solar declination, and maximum solar energy will be received at the latitude equal to the declination. Insolation and seasons. So, how it is correlated, insolation and season? The seasonal difference due to axial tilt and Earth's orbit. So, how season evolved? Because of the axial tilt and Earth orbit. And summer there is a maximum insolation and warmer will be the temperature. Vice versa, in the winter there will be a minimum insolation and then it will be a cooler temperature. In the spring, what happened? It is an intermediate between the hot and cool, and in the polar region there will be a extreme seasonal variation. The factors reducing insolation. So, what are all the factors which reduce the insolation? The first one is the cloud cover. Cloud cover which reflects the sunlight back to the space. So, that is one of the most important concept. And the next one is the dust and aerosols scatters the radiation. So, it scatters away so that the incoming solar radiation is affected. Pollutions which reduces the surface heating. So, the pollution, it does not allow the terrestrial radiation. So, because of that the heating process is affected. Then high albedo surfaces reflect the energy, high energy, and then the atmospheric water vapor which also absorbs the radiation. So, these are all the factors which reduces the incoming solar radiation. Atmospheric scattering, that is short wave radiation scattered by molecules. So, you can witness this one during the sunset and as well as in the daytime, that is the blue sky. So, because of the scattering process only there is a colors in the sky. So, the scattering process mainly influences on the color as in the sky. The scattering reduces the direct insolation. The longer the path through the atmosphere at the sun's rise and set, more will be the scattering. During the sun rise and set, the scattering will be more. And it also influences the colors of the sunlight and radiation received. It is also important for what? The remote sensing and climatic studies. Next one is absorption by atmosphere. So, absorption plays a vital role, that is the ozone absorbs ultraviolet radiation which in turn protects the life forms of the earth's surface. Water vapor absorbs the infrared radiation, and the carbon dioxide absorb the some of the infrared radiation which is mainly influenced in the greenhouse effect. So, the reduced amount of solar radiation reaches the earth's surface. Because of this reduced effect, there is a changes in the weather pattern and then the seasonal pattern also. Morely it affects the local climatic condition. It influences the surface heating pattern and the weather of that particular region. Next one is clear sky insolation. So, if the sky is clear, what happen? If the sky is clear, there won't be any cloud or any disturbance like dust or aerosols. So, immediately what happened? The incoming solar radiation will not be affected. So, because of that, the maximum energy will be received on the surface, earth's surface. It is important for the solar energy harvesting, and the less scattering will be happened, and then the absorption and more direct radiation will be received. So, all these intermediate processes like scattering, reflection, so all will be less in this clear sky process. And it also varies in the latitudes and seasons. So, if there is a clear sky, the incoming solar radiation will be high. Cloudy sky insolation, so it have the disruption, that is it have the obstacles in receiving the or in transmitting the incoming solar radiation. The clouds reflect and absorb the solar radiation. The surface receives a less. There we saw clear sky, there we have discussed about high energy. Here less energy. Because of less energy, cooler temperature will be there, and depends on the cloud thickness, type and coverage. So, in the cloud types, in upcoming lectures we will be discussing about the various types of clouds. So, it has various density, clouds are various density and characteristics. So, because of that particular characteristics, the incoming solar radiation will also be affected. The diffuse radiation dominates under this clouds, and the impact of this one is that the local climate and photosynthesis process is highly influenced by this cloudy sky insolation. Then insolation and latitudinal graph, that is the maximum insolation is maximum at equator. So, in the equator it is maximum, and it varies smooth in the low latitude. So, low latitude it is decreasing. It explains the temperature belt, and it is also helpful in climate classification and solar energy studies. So, by knowing, by understanding these variations, insolation and relationship of latitudes, it is very much helpful in various solar energy studies. Annual variations of insolation. How annually the solar insolation varies? That is the insolation changes monthly due to sun's declination. So, in sun's declination we have discussed in the previous slide. So, that sun's declinations which mainly contribute to the changes in months. And equator. So, equator there is a small annual variations, in the mid latitude moderate variation, but in the polar region that is a extremely seasonal differences. these differences will determine the global temperature gradients. So, you can see the temperature gradient from equator towards the pole and how the sun's declination contribute towards these processes. Insolation and surface heating. So, how the insolation heats the land and water? It is similar? No. The insolation, that is incoming solar radiation, heats land and water differently. Land gets heated fast compared to the water. So, the land heats faster and which experiences the continentality. In the interior of the land, we have discussed about the continentality term, and then in the water which heats slowly and where there is a maritime effect, that is the coastal effect. It creates the temperature contrast, and then winds and monsoon will be prevailing because of this temperature contrast. It also influences the local and regional climate. So, in such a way there is a surface heating and insolation highly related. Insolation and ocean currents. So, uneven heating prevails in the land and ocean. So, because of that, what happened? The temperature gradients in the ocean and it drives the circulation, ocean currents. We have both two currents, that is warm water moves and cold water rises. Warm water will be moving down and cold water will be rising. So, this is the main factor, driving factor which influences the climate of the coastal region. So, there is a moderate influence in the coastal region. So, in the diagram you can see in these regions there will be a moderate climatic condition. It impacts global heat transport. So, because of the circulation it impacts globally. So, we have the effects of Enso and then monsoon. So, these weather phenomena is mainly occurred because of this ocean currents. So, because of this movement, what happens? These special characteristics rises. Then insulation and wind system, that is differential heating, that is pressure differences. So, in the pressure we have all the patterns like low pressure belt in the tropics. So, here you have the tropical region, subtropical region, equatorial region, so polar high region. So, these are all the latitudinal heights. So, it has the wind pattern also, that is trade winds, westerlies and polar easterlies. So, these are all the patterns which is driven by the insolation. So, it also influences the cyclones and global circulations. Because of this wind movement, it highly influences the cyclone and global circulation. Insolation and vegetation. So, insolation. So, without insolation, without temperature, there won't be a vegetation. So, in the seasonal contrast, we have discussed about if there is a dry condition, what happens? There is a stunted or xerophytes will be there. If there is a receiving of high temperature and heavy rainfall, it encourages the growth of vegetation. So, in such a way, high insolation in the tropical forest and then low insolation in tundra and polar vegetation, and seasonal insolation in deciduous forest, and insolation also affects the photosynthesis. Without sunlight, the process is disturbed. It also helps in climate zone and biomes. In such a way, the insolation and vegetation is interlinked. Insolation and renewable energy. So, the solar panel efficiency. So, again here the solar panel is highly dependent on what? Incoming solar radiations. High insolation area, there will be a maximum energy potential. The seasonal and daily variation is mainly considered for this renewable energy, and cloud cover which reduces the solar energy output. So, based on this understanding, so we can plan for solar farms and energy policies. So, measuring insolation. So, how, in what ways we are measuring insolation? That is by using instruments, by using technology we are measuring it, that is pyranometers measures the insolation at the surface, and the satellites which measures globally, and the ground station which validate the data which is received from the satellites, and it records the climate modeling and agriculture planning, and daily and monthly averages which is used for the long term climate analysis. So, it is most important. Now, we are in the process, we are facing the climate change. So, with all these measurement which supports how far we can mitigate all these adverse situation. Global energy balance. See, in nature itself how beautiful that the received glow, that is incoming solar radiation, how it is balanced. That is insolation means incoming solar radiation, we all know that. The some reflected because of albedo effect, and some observed, and some heats the earth's surface. So, this is a cyclic process, all have been done. Because of this process that the energy is balanced, and it drives the atmospheric, ocean and climate system. So, because of this balance only all the weather phenomena occurs in the atmosphere and its surface, and it balances a long wave radiation, that is terrestrial radiation which is emitted by the earth's surface. It is also important to understand the global warming and climate changes. So, in such a way this global energy balance is most important to understand. Human impact on insolation. See, even though one side there is a natural balance, so other side we have the human impact, how the human being are impacted on insolation. So, insolation, because of human being interference, the urbanization process takes place which increases the local albedo by various industrialization and other technological emergence, and in order to meet the requirements of increasing population, this was the urbanization was one of the major impact. The next one is the air pollution, the air pollution which reduces the surface insolation. The next one is deforestation, clearing of all forest, and because of clearing of all forest it entirely disturbs the ecosystem, and it adversely affect the climatic condition, especially the incoming solar radiation. The aerosols and greenhouse gases, it affects the solar radiation and it also disturbs the incoming solar radiation. So, it also impacts on microclimate and renewable energy potentials. Overall, the summary of this lecture is insolation means it's the amount of solar radiation received at the earth's surface. It varies in the latitudes, season and time of day. The equatorial region receives maximum insolation because of direct angle of sun's rays, while in contrast polar region receives minimum insolation, it is because of low angle incidence. The insolation plays a vital role in what? In controlling temperature, weather, overall climatic pattern, and it is also very much essential for sustaining life, supporting agricultural activities and harnessing solar energy. I hope you all understand the concept of insolation. In the upcoming lecture, we will be discussing about the solar radiation. Thank you.